Check, check, check. .NET Fringe is the best conference ever. Check, check, check. Oh, it feels great. I'm going to have to shake my urge to project so loudly. But it's real comfortable in the ear, though. Thank you. All right, all right. Do you need me to keep speaking, or can I switch this off? honestly, with the content. So I think we'll have some more gap after that as well for the first one.
Sean, are you ready to roll? Oh,
Ready?
that's
I'm
where
good.
the mic is. It's on Sean.
Oh, yeah, they said you would use the handhelds. So
Yeah, that's fine.
yeah.
We wanted to get you wired up.
Oh, gotcha. I'm on it, man.
Okay, you want to turn up here too? And you?
So they know who I look like.
Exactly.
Yeah.
Well, we did pink shirt. I tried. Whatever.
Short of putting a neon sign on you, I think.
Yeah, that makes sense.
Hey, Josh, are you timing?
Yeah.
So I've got an app on the iPad that you can just hit start on and it should go if you want. Sorry. If you want to grab me that iPad and make sure it's unlocked, I've got a timer app set up and ready to go on there. It's pretty just need someone to tap it. I wasn't sure if it had locked itself or not.
You want like 5-2 and
Yeah, let's.
It'll do yellow and red, but if you want to signal too,
you
yeah,
could do
feel
five
free.
And then kind of wrap up for
Yeah.
the speakers.
I think I'm honestly going to run under, so I don't think it's going to be a problem. But
Right. I'm Sarah, by the way. Thanks for helping. I just didn't want to do both.
they said Josh was helping. I was like, I know which Josh that is.
That's perfect that you're saying that. So I'll just let the speakers know that you'll do. Don't do it like that. It just kind of like. I know, right? It should be.
where's the one where it comes in like
I know, it starts to dim it out.
Oh, we
I'll cue the orchestra to start playing.
I always tell myself, no one knows what you're supposed to say, so everything's right.
easy enough. I love it.
What else? Okay, he's gonna meet me another go.
Uh huh. So,
That is why I'm not MC. I'm not saying people's names.
Adrian. Can we start the live? Can we start the live stream now to get the? Can you tell them? WWDC is going on right now. You just can't win. I posted on Zero on our Slack. I'm like, got no Fringe live stream. Somebody's like, that's not the Apple event.
oh.
Talk about trying to avoid a conference that would be a
So I picked up the chair and I heard
be
something.
like Apple. There were 300 less attendees.
So I picked up the chair and I just heard like a clunk. I was like, oh man, I look like I cabled enough.
Adrian,
The power just goes out to the building.
Adrian, come on. And we are already behind schedule.
Don't worry, I'll be faster.
Actually, we have a break after the first one.
Yeah,
Great.
yeah.
Live
I'm not gonna.
That was smart.
Yeah.
There's a slight conflict today that it's WWE. It really sucks for Apple. We're gonna have a crappy conference. Not all. So, are we ready? I think we're ready. Is the live stream going? It's going. Okay. Come up here. Yeah. Come up here. You guys can all come on. Hello, we are getting started. How you guys doing? Awesome. Well, thank you for joining us for .NET Fringe V3 2017 in lovely Portland. And please take advantage of the sofas. We have sofas there for a reason. So I want to thank you guys all for coming out. I thought I would tell you just a quick trip down memory lane. A couple of years ago, Troy, Adrian, and I got together, and we were talking for a while saying, you know, we need something different. We need a different kind of event in the .NET community that focuses on the .NET community. And many conversations later there and many false restarts later, we finally put on the first .NET Fringe. And the community came out and we had a great time and everybody loved it and said this thing is magical. And the downside of that is it meant we had to now start thinking about the next year and the next year. Maybe it's not a downside, but certainly not easy putting these things on. But we're really, really excited. We've got an amazing lineup of speakers. And we're also really excited about the momentum that is happening in the .NET community. The community really is taking the reins, doing some really, really interesting stuff that you guys are going to learn about. And of course, we've got some really exciting things coming out of Redmond, coming out of Microsoft, like .NET Core. So it's a really, really good time to be a .NET developer. And this event is really for you. So thank you guys for coming, and we really look forward to spending time with you over the next few days and to moving forward with .NET Fringe. So I'm now going to pass it off to Troy.
Hello, hello. Hey, everybody. I'm Troy. Hi. Did you see these cool couches up front? These are what I like to call first-class seating. Unfortunately, nobody's taking advantage of it. They're almost completely empty. I really don't know why you wouldn't want to sit in a really, really sweet, comfy couch, because that's where I want to be. But I would encourage you to come up here and relax. These are not reserved. These are for you. In fact, this whole conference is for you and for the people sitting next to you. Always feel free to start a conversation with somebody you don't know. Introduce yourself. Did everybody get a conference bingo sheet? Yes? All right. That has a bunch of really interesting stuff on it. And if you start crossing things off, you'll get a fabulous prize at some point, I promise. But one of the things that's in there is introduce yourself to somebody, meet someone new, invite somebody to your table, these kinds of things. So try to reach out to people you don't know. That's what we're here for. I want to show you this thing. This is really cool. This is something that'll be relevant upcoming. So whenever we have a break or something like that, instead of blasting your eardrums with our loud voices on our mic, we are going to very gently let you know that it's time to quiet down and start paying attention to what's happening by ringing this really nice bell. Here you go. Hold on. So when you hear that, something's happening, and you should pay attention. All right. So the next thing that's happening is that Adrian Hall is going to tell you a little bit about his part of this conference.
That's cool. Morning, everybody. So, earlier I ran the bike ride and I also organized the Geek Train, which future events note to join the bike ride and the Geek Train. It's a lot of fun. And that was my part of the conference this year. I'm mostly here attending this year, which is so awesome. I feel so irresponsible.
Thank you, Adrian. And next we'll have Sarah Ford telling you about her awesome role in this conference.
Hey y'all, I am speaker wrangler, and that means I will be meeting speakers when it's about maybe 5 minutes or so, 10 minutes before you talk. I will take you backstage, our awesome backstage here, which will also be known as my office for the day. And yeah, so I'll just make sure that I'll be wrangling speakers. So thanks.
Hi everyone, thank you all for coming. It's really great to see lots of people. We got a lot of proposals coming in through the CFP, and as a result, we should have a great lineup today. So, thanks.
Hi, I'm Maria, and I'm just a volunteer at the registration table. If you guys have any questions, just let me know.
Hey everybody, I'm assisting Maria out at the table, and if you haven't grabbed one of those bingo sheets that Troy was talking about, we got plenty left out there, okay?
So I'm Byron, and this year I'm the volunteer coordinator. And like Glenn was saying, this is a community event, so the entire thing is volunteer run. So if anybody needs anything, please come to me or Troy, anybody. But all the spaces like the unconference space, registration, putting out the, power plugs and everything like that, it's all volunteers.
Also, don't forget, we actually have massages and acupuncture, and you want to take advantage of that. It's really,
That'll
really
be
good.
coming up at 11 o'clock. Yeah. There's also going to be some cool stuff happening downstairs in Lola's room. I don't know if you've managed to make it down there yet, but downstairs, one floor, we have this space called Lola's room, and we're going to have unconference down there. If you've never heard of an unconference, it's where you get to kind of sign up to get a spot at a table to talk about whatever you want to. Mark Davis is down there coordinating that, so if you don't know what to do, just go ask him and he'll help you out. We've also got an IoT lab if you want to play with hardware and do some hacking on sensors and get into the real world a little bit. And if you don't like the real world, we have the VR lab downstairs, which is a virtual reality setup where you can go and explore alternative experiences in the digital realm. There will be 2 of those. They're still getting set up. It's not quite ready, but I encourage you to venture down there and check out what's happening downstairs as well as what's happening upstairs. All right. Without further ado, we're going to bring up our first speaker in just a couple minutes. Thanks.
And in case I forgot to mention it, I'm Glenn, and I will also be your MC for this event. So without further ado, our first speaker has been patiently waiting behind the veil, and I'm going to bring him out now. Sean Killeen works with Excella. He's also been a great friend of our event. This is his 3rd time attending .NET Fringe, and now he is speaking, so take it away, Sean.
Thank you. Thank you very much, Glenn. Good morning, everybody. Welcome to .NET Fringe. Can everybody hear me okay? Fantastic. So I want to say I am incredibly excited to be here at .NET Fringe this morning. In a moment, you will see some slides that talk about how excited I am to be at .NET Fringe this morning. But it is my 3rd time at the conference, so a hat trick for me. It's been one of my favorite venues and my favorite spaces to meet so many great .NET developers and folks who are performing great work in the .NET space. I'm going to go ahead and make sure that my slides are up here. All right, let's try that. Great. All right, so very grateful to be here. My name is Sean Killeen. I am a consultant with Excella Consulting in the Washington, D.C. area. So we build software solutions with Ruby, Java, .NET, Python for commercial, nonprofit, government clients in the area. So I'm grateful that they allowed me to ship out here to Portland for a few days. I've been a .NET developer for about as long as I can remember, starting with the early days. And one of the things that I wanted to talk about with this conference in particular is that it's a sort of family-oriented conference. And this conference has always felt like a big family space to me. So I wanted to call out this guy right here. This guy's my dad, Jim Colleen. And when I first started developing in .NET, it was because my dad was developing with .NET. And I was curious and I wanted to learn more about it, and he had an incredible amount of fortitude and patience in dealing with me and helping me learn these things. And also, one of the other things that spurred me is that I remember when I was a little kid and an older woman wandered up to our driveway at our house, and she was lost. She clearly did not know where she lived. And I remembered my dad spending a large portion of time driving around the neighborhood to try to help this woman find where she lived. And to me, that said a lot, because his message to me when I asked him about it was that if you can help someone, you should. And to me, that's what open source means to me. And when .NET folks get together here to help each other out and talk about open source and talk about what we can do to improve the community and each other's lives, to me, that's what this is all about. So it was my dad's birthday recently, so I'd just be remiss if I didn't throw in this little birthday present and say happy birthday, Dad, and thanks. So we are here today standing on the shoulders of giants. We have people here at this conference who are doing incredible work with Microsoft, with GitHub, a ton of open source maintainers that are here, and so it's wonderful to be amongst you to speak about this topic. It also has me feeling a little bit like, I would say, the expert beginner, if anyone's familiar with Eric Dietrich's cartoon about the expert beginner. So someone who just knows just enough to think that they know a lot, but has a long way to go. So I hope to be slightly more self-aware than that, but I do feel that I have a long way to go, but I'm grateful to be here sharing these things with this audience. So that reminded me of a great tweet from the expert beginner that I saw a few years ago, which was that you can't trust open source, that's why we've always been a .NET shop. And it's amazing how relevant that joke was 2 years ago and how much less relevant it is now. Going in the right direction, I would say. So whenever you talk about open source with Microsoft, there's always a sort of elephant in the room. And I've always been caught between these sort of two generations. I've been around in the ecosystem long enough to understand that Microsoft has a slightly checkered past with open source, and that there are always a number of people who sort of experience those days and put in a lot of effort to try to make that different. I've also am new enough to the ecosystem to be completely excited by what's happening in the space currently between .NET Core and all of the open source projects that we're seeing out there, and the fact that Microsoft and many others are trying to bring back a sort of open source renaissance for the .NET age. So I'm encouraged by that, and I'm very excited by that. And the problem is that we have these sort of, as a result of this culture, as a result of this, I would say, focus on making sure that developers have what they need from Microsoft, we created this sort of the dark matter developer. I think Scott Hanselman coined the term. And so that developer toiling away 9 to 5, building things, being productive, not necessarily on the radar. And so how do we reach that developer to bring them forward? You know, we've created a space where these folks are being productive. They may not be as aware of what's available in the community. So how do we make these opportunities available to them? And so it's sort of, we have this problem of cultural debt. We're trying to tackle how do we move a culture forward when we have this sort of weight bearing down on us from future or from past notions of how development should work, and the sort of cultural debt that has crept into the ecosystem over time. So I'm going to talk a little bit about how we identify that and how we move that forward in our own companies and our own careers and for others in the ecosystem, most importantly. So we want to make sure that we can jump that hurdle. So this cultural debt problem, how do we tackle such a problem? We tackle it with a whole lot of empathy. You know, imagine all the empathy you can muster and the understanding that you could have for the situation that someone's in, and then go further than that. And try to understand where these companies are currently, and so that we can understand their perspective and begin to move them forward. So there's a great quote that I saw from Woody a little while back. A simple rule when he follows when working on legacy code: honor the coder and their code. The constraints they endured are not mine to know. Similarly, I think that as we try to move companies forward in the open source space, we have to be aware of their constraints, respect them, and meet them where they are to try to move them forward. And so what I'm asking is that we sort of apply this philosophy to the culture at large of companies that are starting to expand into open source and companies that are starting to improve their journey towards being open source contributors or to understanding that wider ecosystem outside of their own companies. So I was thinking a little bit about this at the last .NET Fringe, actually, as I saw folks talk about companies in different areas of the spectrum and how to move them forward. And so I was thinking about sort of an exciting way to capture this. How can we get everyone's attention? How can we find something to move us forward? And so I came up with an incredibly exciting concept of a maturity model, because everyone loves maturity models, and they're definitely the most exciting thing, and who could not possibly be excited by a maturity model? But I found that the more I thought about it, the more a maturity model made sense, because we would allow companies to understand, or developers to understand, where they are on a given spectrum, and to work toward moving forward to the next step. And by identifying where someone is in a non-judgmental way, we can provide a path for them. We can provide a bridge and begin to move them forward. So I want to talk a little bit about this model, how I've defined it, and then how to move companies through some steps on this model. So the beginning of this model is largely concerned with fear, uncertainty, and doubt, or FUD. This is where a lot of companies and developers start out on their open source journey. Things seem really strange and scary. It's a whole open ecosystem. It could impact your business. It could impact your career. How do you approach this sort of work? So there's this idea of mistrust of that wider world. That is unknown. It is out there. My safe space of my code and my company is in here. And if I bring something in, it's going to be very intentional and very risky from my personal perspective. And so as I'm thinking about that, the first stage is going to be a sort of mistrust. You also are concerned with things like legal options, right? How are all these licenses working? Does this project even have a license? Am I going to be unable to use this if I, say, violate a patent? Or am I going to be able to use this if I'm competitive with a certain company? These are the kind of things that companies and developers who are bringing this software in tend to be very concerned about at the beginning. Similarly, companies currently in this stage like reinventing the wheel. They think, why would we use someone else's? We can build it in here, know exactly how it works, have all of that. So we still have that mindset that we're dealing with in terms of how do we actually understand and get people to move away from that reinvention of the wheel. The other concept that I've termed in this way is that as you're working at a company that's not as familiar with open source, but feels very confident in the ability of their developer teams, if they can build it, then certainly they must be the best. If they can build it, then their standing is confirmed. They have made it work for themselves. It's an accomplishment that they can point to and be proud of. So in this fear, uncertainty, and doubt phase, the fact that all of these other similar libraries or similar options exist out there can sometimes feel like a threat to an internal development culture. And so we need to sort of work on changing that as well. So the next stage of the model, once moved from fear, uncertainty, and doubt, is acceptance. So at this point, the development teams have accepted that open source exists. It may feel a little bit like a mystery. Or it exists, it's out there, it's this interesting mystery of open source, and it's nebulous and it's strange, but maybe they're intrigued by it, but they at least accept that it exists. They acknowledge the existence of an ecosystem. And then this part also involves learning the moves. What the heck is a fork? What is a pull request? What are these concepts? How do I understand how to operate with this ecosystem? Some cases it might be, what is a package manager? Some of these folks might say NPM what, right? And I think that's a thing. So we still are dealing with folks at this point who understand that the ecosystem exists, but need to be moved forward in terms of what are the moves. So similarly for consumption, as I mentioned, using packages is going to be important. So in the consumption phase of this model, What we're dealing with is a company that understands how to appropriately consume software from an open source world. So they understand package managers, they understand the versioning and the dependencies of different packages. They probably have some sort of a build setup where they can make use of these things and repeat them. And so in this model, we have folks that are using packages, they're making good use of NuGet and NPM or Yarn or whatever the JavaScript package manager du jour is, and making good use of that. They understand the ecosystem, they understand how to pull software down. They may not necessarily be contributing back yet. So in this phase, OSS starts to feel a little bit like magic. So it's gone from a mystery to, oh, I can pull all of these libraries, I can do these fantastic, great things, wonderful. And so these companies start to get excited, devs start to bring in a lot of libraries, in some cases maybe more than they need, but the idea is that the developers and those teams and those companies are starting to be more consumer-driven about these products. The other piece of this is responsible consumption. And what I mean by that is users of open source software understand how to submit appropriate issues. They understand how to ask a question or not just flame a repository because it didn't do what they wanted it to do on the first try. So in this stage, responsible consumption, folks understand that maybe they should submit a pull request even though they might not know what that is. They understand what an issue might be. They understand how to appropriately describe a problem or reproduce a bug, or if we're really lucky, produce a test case that fails. So we have this idea of responsible consumption. When it's not done well, it starts to turn into this customer is always right sort of mentality of open source. So responsible consumption, rather than being like Dwight up here, says that the customer is more polite and more realistic when dealing with open source maintainers and the expectations around them. It also may mean that they are familiar with the responsibilities that OSS maintainers have and sort of have empathy for those sort of tight schedules and all of the usually charity work that goes into maintaining an open source library. So moving towards contribution now we've reached the phase where we are no longer just intelligent consumers of these packages. Maybe we want to get our hands dirty. We want to contribute back. So in this phase, developers are going to start to understand what the concept of pull requests are. They also start to see open source software as more of a two-way street. It is no longer just consumption. If I have a problem, I can fix it, or I should at least dig in and try. If I have an issue, I not only know how to submit that, but I will definitely do my best to submit the test case and to submit a PR if I can, and to make those things happen. So at this point, development teams and companies see open source as a two-way street. So afterwards, we want to expand the horizons a little bit. So if I'm a development shop and I already have developers who are occasionally contributing back, I as a company may want to encourage them to participate wider. As a company, I may want to open source some of my own software, find a library and put it out in the world for consumption. This can be very scary for a company at first. It also means encouraging contributions from others and really incentivizing developers at your company to start participating in the open source community. So in this case, you're going to be OSS by default. If there's an open source solution, you're probably already interested in it, and you're pulling it in, and you're thinking about how to incorporate that. You are going to be setting up public code as much as possible. Is there something we can open source? Not is there a compelling reason to, but why not open source it? So open sourcing by default and making your company's code public as much as possible is where a company would fall when they're in this sort of participation model. They are participating in the wider ecosystem. So they're encouraging contributions from developers, and in one case, for example, my company, Excella, what they do is they have what's called an expert program. And they actually have a sheet of points for different activities that you can do that are incentivize you to reach another level in the company. And one of the ways you can do that is by contributing to open source projects and open source code. So there are ways that companies can incentivize developers to do this and encourage them to do this. The other way is that we have an Excella Labs project. This is an open source space where employees can hack on projects together, where if you have an idea, you can put it out there for the Excella community and beyond. And so a large portion of this is finding a space for employees to contribute, letting them know that it's important to give back because they're gaining skills, they're gaining community involvement, and others are hearing more about the development work that you're doing at your company. So the last step on the model, which I think is really difficult to obtain, is this idea of what I'm calling the cultural embrace. So the cultural embrace means going beyond just having your code out there and accepting contributions. It also means sort of avoiding not invented here syndrome. So if an open source library exists that does what you need it to do, can you use that instead? Can you collaborate with that library? Can you make use of what already exists in the community, in the ecosystem, before putting your own product out there into the world? Is there a way that you can merge with that ecosystem or take into account the great work that already exists out there in the environment? The idea of a public roadmap is also key here. Embracing open source kind of means being open, in my opinion at least, about where the direction of a project is headed. If you can be open about that and show not just your code, but the direction for that code, the organizational model behind it, the governance behind that, you're going to be able to, one, gather more contributors, but two, you're also going to be embracing the notion of existing as members of this larger community. So this one's really hard to obtain, community direction. So when thinking about community direction, it really means ceding some of the control about where the product goes to your users, whether that's intensely seeking out feedback and moving towards that, or whether it's allowing users in the larger community to make decisions about forks in the road for your project. Seeking that out rather than sort of informing the users or the consumers of your library flips this idea of open source and really opens it up to all of your consumers to be able to make the decisions around that. It's easier for some companies than others for sure, particularly those companies with large bases of stakeholders or large bases of disparate stakeholders. But sort of achieve this step, it's sort of about seeding that direction to your users and your community and making sure that you have the ability to allow them to drive things. It's also collaborative by default. As I mentioned, if you, as an open source company or development staff at this level of the game, if you are able to seek out a solution, chances are you're looking to collaborate with someone else on that solution. You're not necessarily looking to produce it from within. You're looking to actively bring others along with you. And so at this stage, the cultural embrace, it really is about opening it up and bringing as many others along with you as possible. And as I mentioned, that leads to being maximally open. So you are as open as you possibly can be with your direction, with your governance, with your organization, with your code, and with the way that you process your workflow. So how do we help people get to the different rungs on this ladder? How do we help move folks forward on the maturity model in open source development? So, it's sort of help me help you. What can we do to get you to that next step? So moving from the fear, uncertainty, doubt to an acceptance standpoint, you're talking about explaining the advantages of open source or pointing to articles about that or helping to educate people on the ROI of open source, on the cost savings, the time savings, the efficiencies, the ability to take advantage of the great work that others have done and to contribute back to it. You're also doing things to introduce them to licensing. What different licenses mean? What do they mean for you as a business? Are there licenses that make more sense or less sense? How do you as a business want to adapt an approach to open source software and adopting it? So it's about helping people understand those questions to remove some of that fear and uncertainty. Success stories are always helping too. I mean, we have huge examples of success stories just in this room alone between all of the work being done at Microsoft and GitHub and the umpteen other fantastic open source projects and companies that are represented here today. So I'd encourage you to sort of think about that in terms of success stories. When other businesses hear how it can be done and hear about the recognition and the advantages that come along with that, it gives them an additional incentive to move forward. Myth busting is also a large part of open source software and getting companies on board and out of this stage. You have the myth that open source software isn't secure, or the myth that, or rather all open source software isn't secure. You have the myth that open source software contributors are nasty, or that you're going to have to go up against a Linus Torvalds every single time you try to commit to a project, right? So understanding and helping people be aware of what the community can be out there is going to help them move towards accepting that open source exists. So moving from acceptance to consumption, we've got to educate folks on the best ways to make use of open source software. So package managers and things like that, how do we consume open source? How do we get it into our lives, into our projects, and helping our companies? What are the best ways to do that? Are there pitfalls that companies could avoid by doing that? And so helping companies understand how to manage their packages or how to manage their consumption is going to be a big part towards moving that forward. Talking about what responsible consumption means. As I mentioned earlier, telling them or explaining to folks at this stage of the game that understanding how an OSS maintainer's schedule tends to be or what the burdens tend to be on those who maintain open source software, combined with educating folks on what the appropriate way is to send an issue into the community, or how to read contributing guides, or how to understand how to fit your expectations in with that of an existing open source project. So helping folks understand what responsible consumption means in this case is going to sort of increase the, or decrease the headache for the open source maintainers as we try to bring folks into this array. A lot of folks who are going to be contributing or are going to move from consumption to contribution don't necessarily know how to do so. Maybe they're not working or familiar with Git or GitHub or GitLab and what these things mean. So how can we sort of evangelize those platforms and processes and ways to give back? So we're going to do that with sort of moving folks forward on the Git and their platform fundamentals. Also, making use of a great site called upforgrabs.net in our case would be very helpful here. So for those of you unfamiliar with Up for Grabs, are any of the maintainers of Up for Grabs here today? Up for Grabs. Sorry, Glenn, not your turn. But if folks are here from that, please find them. Upforgrabs.net is a fantastic site that lists open source projects that are welcoming for first-time contributors and seeks to help get people started in the world of contributing to open source software in .NET. So it's a fantastic project, and that's one of the tools that we can utilize to move people from consumption to contribution. Similarly, answering the why of contribution and why contribute to open source. My journey for contributing to open source started right at .NET Fringe 3 years ago, actually. And so one of the things is I'd done some sort of oddball contributions to open source, and I kind of started a repository, and I kind of knew what that meant. But really understanding the way folks worked at .NET Fringe got me involved with the Akka.NET project, where I met a lot of people. It helped me submit a pull request to Phil Hack's blog. It helped me submit pull requests to all of these projects that I'd come to appreciate, and I found that I could make the world a little bit better, a little bit at a time. So helping developers understand what the advantages are for you, not just in terms of visibility or recognition, but in terms of the joy of making the world around you a little bit better at a time, the more we can do to help developers understand the why of contributions, the more we're going to be able to get them to move towards open source. And that sometimes just means re-explaining, or explaining again, or providing a resource, or reaching out to folks who we thought would previously be inspired but haven't quite gotten there yet. How do we reach out to them and bring them along and reiterate these great advantages? So guides from moving for a contribution to participation for a company, guides to open sourcing software are going to be helpful. How do you as a company take a piece of software that is maybe closed source now or internal and move that towards an open source platform? What is the process involved with doing that? What are the pitfalls that you can avoid? Several people here in this audience have done exactly that. And so helping folks understand what the pitfalls are there, what's involved, what the massive effort could be, or what the minimal effort might be in their case, is going to go a long way towards opening up companies for participation. Also talking about what the return on investment of that participation is. The fact that as a company, you're making use of this software that is going to increase your efficiency. You're not going to reinvent the wheel. It's that much less code for you to personally maintain. You're able to collaborate with others. You're able to interact with other developers, other styles of development. Your developers, your teams, your colleagues are going to level up their skills by interacting with others and understanding different ways that software developers think. So in moving to participation, making sure that businesses understand that ROI, that investment, and what they're getting for it is going to be crucially important. Also thinking about ways to encourage contributions. So as I mentioned, with Accela, we have that expert program, and we have the idea of this open public space for employees to get used to the idea of contributing to open source and build work on real projects. And employees are also they are also encouraged to give back to the open source projects that they use on a daily basis. So helping companies understand what the method might be for creating some sort of program like that, or ways to incentivize their employees, are going to be a big help. So similarly, not just encouraging participation, but incentivizing it. With that expert program and a point system, Accela is able to make use of and say open source is important to us, and it's literally this important. And we can assign a value to that, and developers understand exactly where Accela's priorities are on that. And so that's something that I've been grateful for, because it tells me as a developer that my company is not only okay if I contribute to open source software, but that they are excited by that and that they want to put a lot of effort in to enable me to do that. We also want to talk about moving from participation to cultural embrace. And this is the hardest part, and it's one of the last pieces that a company can obtain. So committing to collaboration first, saying before we want to provide a solution, we're probably already pretty successful in this industry, we're probably already have a pretty good public presence in open source software. How do we commit to collaborating first? Before inventing some new gadget or some new library or some new piece of software, can we find where the seeds of that might already be and work to bring that out in the community? Can we commit to collaborating first before we seek to do things internally? Also, taking feedback on things like non-invented here syndrome seriously. If a community points to something that says, this great library exists already, so before you start down this path, have you considered this? And really trying to take that feedback seriously if there's momentum around a certain community or certain libraries that already exist. So providing examples of a public roadmap can help companies and help them understand how to govern openly and make sure that they understand how to publish a roadmap. What does that look like? What can users get out of that? And how do you solicit user feedback once you have that roadmap public? Similarly, providing examples of community-driven open source software that really is determined and shaped by the community, and helping folks understand what some of the attributes of that might be can go a long way to participating and getting companies to really embrace that culture. Similarly, open governance models, helping folks understand not only how they run the software and how they build the software, but how others can be involved and how others can shape that process. And so I thought about this a little bit, and I thought, I wanted to do something about this. I wanted to actually start to try to help people move forward in open source. So I had this idea of castingawider.net, and I looked, and that domain was totally available. So I went and I snagged that domain, and I figured what better place than .NET Fringe to launch that website. So I figure I'm going to go ahead here and pop on over and launch that site right there. So that's a GitHub Pages site. Dave is here somewhere. I'm going to talk to you. So we should see that in a second here at awider.net. I can't see if I typed that correctly or at all. awider.net. So the styles are not quite there yet. Hopefully soon. Or I accept pull requests. So feel free to do that. But seriously, I'm interested in collaborating with others on this and helping to understand how we can move things forward. So I am asking you in this moment, please provide your feedback on whether this model makes sense. Please reach out to me about ways that you think we might be able to move people forward. And by all means, work with me to help cast a wider .NET for everybody. So thank you for being here and for this fantastic experience and allowing me to open up the conference. And you have a great lineup of speakers today, so thank you very much. Appreciate it.
All right, thank you so much, Sean. So we'll have about 15 minutes after the talk for a discussion period. And what we encourage you to do is turn to the other people at your table and talk about what Sean was just talking about, your feelings about it, what it means to you, how it could change your work or your passion project or whatever it is that you thought about when you were listening to Sean's talk. 15 minutes and we'll be back.
Okay, I'm very excited to introduce our next speaker, Katie McCaffrey. Some of you might have heard of her. She is a back-end brat and a distributed systems diva. And she works on this distributed system. It's kind of big. You might have heard of it. It's called Twitter. She works on the back end, and she's going to be talking to us about microservices and sagas. Take it away, Katie.
Great. Hi, can you all hear me? Yes, sounds like I'm on. Okay, thanks. So I'm super excited to be here today. So I am Katie McCaffrey. This is where you can find me on the internet. But prior to working at Twitter, I actually worked at Microsoft for 5.5 years on video games in the .NET community. And worked with a project called Orleans, and so I think Sergey is going to talk to you guys about that later. So it's really nice to be back in part of the .NET community. But today I'm going to talk to you about something that's actually kind of protocol and language agnostic. So let's get started. So back in the day, we used to sort of build these systems, these big monoliths that could horizontally scale out. And we had all of our sort of like concurrency and consistency problems were isolated to our single database. Often this was like a relational database like SQL. And things just sort of worked because we were at the scale where everything would sort of fit into one giant database that you could vertically scale up. That stopped being the case, and so we introduced this concept of like microservices and NoSQL for more availability and scale. And so we have these like systems that sort of look like this with all these different languages and all these different NoSQL databases with different kinds of consistency guarantees. And this has a lot of nice benefits, like we get higher availability with some of these NoSQL databases. We can scale out larger than one machine. We allow developers to operate in the languages that they like. And then also we like allow them to deploy faster. But it comes with a lot of challenges, right? Because now like we've sort of made our consistency and concurrency models much more complicated because all of our data is spread out all over the system and no longer in one database. And so Peter Bayless published this paper that's focused on Ruby, but I think introduces a term that I really like and this sort of describes the world we live in today called feral concurrency control. And basically, feral concurrency control is this application-level mechanisms for maintaining database integrity. And we'll walk through an example of what that looks like. But basically, it means the database no longer is our source of truth that enforces all of our consistency and concurrency guarantees and the invariance for our system. Instead, it's sort of spread out in application-level code. And so this comes with a lot of challenges because developers have to code this on a day-to-day basis. And it's easy to get wrong. So let's look at an example of how we might start building an application in our microservices architecture today. Say I'm a travel startup. I want to help people book hotels. So I'm going to have a hotel service which will have its own data store. And the invariant we want to enforce is that you have to have a hotel reservation before I will charge your credit card. And so the way we enforce this guarantee in code is that I make the hotel reservation. If I can secure a hotel reservation, then I will forward a request from the hotel service to like some payment API. And the payment API will then charge your card, et cetera, et cetera. But this is a feral concurrency control mechanism because a developer has to code the causal chaining of events in here of book the hotel and then charge the credit card. It also has to handle things like what if we can't charge the credit card? Then I have to free up the hotel reservation that I held in your name because I couldn't charge you for it. And things like that. So this is all like, you know, bespoke, artisanal, developer-crafted code to enforce our system invariance. And so great, so we can do this and then say we're doing really well, so we want to help people book cars and we want to help people book flights, and this is how a architecture might evolve. This is totally reasonable. We can have different teams work on each one of these services. It scales very nicely people-wise, but you can sort of see that this is getting a little complicated. Now, product wants to introduce a new feature called trips, let's say, which allows the user to specify their location, dates that they want to book for a trip, and then we'll just like go book it for them. And from a product perspective, or like if you've ever worked with product and they're like, why isn't this just easy? You already have all the parts. You can book a hotel, a car, and an airline flight. Like just go make it happen. It should take like 2 weeks. And you're like, not really, because first we're going to introduce this trips system microservice, which will have its own data store. And it's going to store all the information about the trip, which makes sense. But this has a ton of feral concurrency control mechanisms inside of it because it has to handle talking to all of these other services and what happens if one of them fails. It also has to handle the fact that what happens if the trip service processing your request fails in the middle of the transaction or the business request. It's not really a transaction. And so you hold some reservations and not some other ones, and like, what do you do there? You have to clean it up, otherwise you essentially have a leak. And so this is complicated code to write, and it's difficult to get correct. So it takes a long time. And so this is sort of like our resulting architecture for some fairly simple services that I've just like, made for this example. You can sort of start to see how we end up with things like this, which are Death Star architectures. That is Netflix, that is Twitter. These are really common when you start having these systems evolve over time with microservices where they're like just sort of evolving because a team's like, I need a service here and it talks to Cassandra, and I need a service here and it talks to like Cosmos DB or whatever. And this is what happens, and they're really, really complicated and difficult to maintain, and they're more difficult to modify over time. Because you have to have a more holistic view of the system and everything it touches to understand all the different concurrency and causal relationships that are encoded in the system itself. Okay, so can we do better than feral concurrency control? These systems are really difficult to maintain and modify, so like, how do we make our lives easier? Because this gets like kind of crazy after a while. So what about Spanner? Spanner is Google's globally distributed database. They actually, I think, just GA'd it like last month. So basically, it's a Google scalable, multi-version, globally distributed, and synchronously replicated database. So it has transactions. It's essentially like running a relational database across the globe. The way they guarantee distributed transactions with 5 nines of availability is they have this thing called the TrueTime API. They have a massive amount of hardware, fiber between data center and GPS, and atomic clocks installed on individual machines, and a ton of redundancy. So that's why it really is a CP system if you're familiar with the CAP theorem, but they people, their marketing department says it beats CAP, but that's like stupid. It just has 5 nines of availability. So that's really great and a great feat of engineering. So like, why don't we just all use this? Like, problem solved, right? Well, Facebook basically published this paper in 2015 saying like, probably not, because it's a 7-page paper, and I highly recommend reading if you're interested in this, but it boils down to the biggest barrier is that the consistency mechanisms must integrate across many stateful services. So part of the reason they're using microservices and denormalizing data is so that they can optimize all of their different like querying workloads to be really efficient. So they'll denormalize data in one format over here so that they can query it really fast for one use case, and then they'll denormalize it over here so they can query it really fast for some other index search. And they're basically going on to say strong consistency across all the systems would result in higher latencies because you're basically now bounded by the lowest machine or the slowest machine in your cluster. And they also posit that users will tolerate inconsistencies over high latencies. So Facebook is like, we're not going to adopt Spanner or even like some of these stronger concurrency control mechanisms like causal that are out there in research today and are known like sort of solved problems because it would add too much latency back into the system. Also, it's worth noting that like we already have this atomic commit protocol that will do distributed transactions across stateful services. It's called two-phase commit. I'm going to run through it super quickly if you're not familiar. Two-phase commit, it has 2 phases. It's very aptly named. It has the prepare phase where everyone will say like there will be some kind of coordinator which will say go do this thing. Or like, can you do this thing? It'll propose it. Everyone will then vote and say like, yes, I can do this thing, or no, I can't do this thing. And then the coordinator, once it receives all the messages, will say everyone either go commit the transaction or abort it. And then finally, because it's a distributed system, everyone has to say I'm done. If that was a super quick run through, if you want to know more about that, Henry Robinson has a really great blog post about two-phase commit on the paper trail that I highly recommend reading. But basically, the reason we do not use this in industry is because it doesn't scale. In the worst case, it has O(n)² messages. You have a coordinator, which is a single point of failure, so if the coordinator fails, like your transaction's done. You're gated by the slowest machine in your cluster not once, but twice throughout the protocol. And it has reduced throughput because you're essentially holding locks in these systems. So while you do get distributed atomic transactions in the asset sense, it has a lot of scale challenges. It's worth noting that Azure actually has a blog post specifically stating they don't implement two-phase commit inside of Azure because it doesn't scale and for liveness reasons. And major RPC frameworks like Finagle and gRPC do not support this. So I think it's pretty clear that like we're not going to use this in industry because it doesn't scale for like very large use cases. For like one-offs where you have 1 or 2 participants and you're going to use this very rarely, it does sort of work, but does have known liveness issues. Okay, so instead I want to tell you all about a protocol that I've been sort of working on and using that came up in Halo when we started working on that in those days, and it's called Distributed Sagas. And the goal here is not to give you ACID transactions, but to help sort of simplify how we program and give you an understandable model and some very fairly strong guarantees that will help make building your systems easier. It's worth noting that we started looking at this in Halo for building the Halo statistics services and some other features that basically we implemented a very bespoke version of this that worked just for us. At Twitter, I've been working on integrating this within our distributed build systems. And then also, it's worth noting that I went and sat down and talked with Uber because they were having this problem of their giant Death Star architecture and how do they modify and make more use of their services. And so they're actually starting to implement a version of this internally. And Matt Rainey talked about that at YOW 2016. So this is sort of getting some traction. So what is a saga? Sagas is this idea that came from a paper on 1987 that was published, and in the context, it was just a single relational database. And the problem they were trying to solve is that sometimes you have these really long-lived transactions in a single relational database that take a really long time, but because it's a transaction, it holds locks, and therefore it becomes really, really slow. So basically, they say, what if we can break up these transactions into tinier sub-transactions, and then the sequence can either complete totally, like all of them commit, all these sub-transactions commit, or like compensating transactions are ran to, so basically the system is back in a comparable state to before the saga started. So that's the relational or database, sort of single like machine relational database approach to this. And they sort of do this, the typical, 1980s distributed systems or database paper thing where they're like, oh, clearly this could be like turned into a distributed system. And it's like, cool, but that was actually a little harder than maybe just like taking your paper and implementing it. I came across this paper a few years back and found it interesting and was wondering if we could apply it and formalize it in a distributed system because we sort of care about the same things. We want really high availability and we want to preserve application invariance, and that is what the original paper is going for. And so this is I'm going to share with you guys some of the progress we've made refining it over the past couple years. So basically, a distributed saga, we're going to define it as a collection of requests, so like our book, hotel, car, flight, and charging money, and compensating requests that semantically undo the request in the saga, so canceling a hotel, car, flight, refunding money. And these things represent a single business level action. So either if they all complete, then the business level action was done. If you ran them and then ran all the compensating requests, then it looks like nothing happened in the system. So let's talk about the requests in a distributed saga. What are some of the invariants that we have to enforce on this? Requests can abort, so you can say, hey, I want to book a car, and the car service can say, no, I don't want to do that because I don't have a reservation. That's totally fine. Requests must be idempotent. So this is basically the idea that if I run it multiple times, and then I get the response, that it has only happened once. And so that's fine, and that's great because then if there's a timeout or some kind of failure, we can retry it in the system. The other reason we want, I mentioned this. The other reason we want requests to be idempotent is that basically, if I make a request, a timeout occurs, I want to be able to remake that request and have it be safe, and then have it only have it taken place once. Because when a timeout happens, that's our best approximation that a failure has happened, but we are not guaranteed that a failure has happened. So that request could get through. So if you were incrementing a counter, that's a non-idempotent request. For distributed sagas and compensating requests, these have some other invariants that we have to uphold. Like I said, they have to semantically undo the effect of a request, but they do not have to roll the system back to exactly the same state. So some good examples of this is in our example, if I charge your credit card and then I issue a refund to that card, you actually may see two line items on your bill of I charged your card $500, I refunded your card $500. So your balance is semantically in the same state, but actually you see the effects of the two sort of requests in the statement. Another good one is if you send, say, a push notification or an email, you can't unsend that usually. So your compensating request could be sending a follow-up push notification or a follow-up email to correct whatever you said in the first one, to say hey, sorry, we messed up, here's a credit, or whatever. And so those are what compensating requests sort of mean. You can have these things that take place and have side effects in the real world, and as long as you're okay with a business level compensation for them, that is totally fine. Compensating requests cannot abort. So the reason this basically is that in order to provide the guarantee that we can always run them to completion, they cannot say no, I can't cancel this request. They always have to succeed. Compensating requests also must be idempotent. So this is the idea that like I want to be able to rerun them until it succeeds, so that has to happen. And then compensating requests must also be commutative. And I'll walk through why, but commutative basically means that if I run book car and then cancel car, it's the same as cancel car, book cars. This is like addition. Addition is commutative. And so the reason we want this is this is a time diagram. Time is going down. If something says book car, and we get a timeout because it got delayed in the network and it took too long to get there, we don't know if it got there or not. So I'm going to run book car again. That's totally fine. I'm then going to like maybe cancel the car reservation. And now my pesky first book car request decides to arrive. As long as our requests are commutative, we don't actually hold a reservation anymore. This is totally fine. So in summary, requests must be idempotent and can abort, and compensating requests must be idempotent, commutative, and cannot abort. This may seem like sort of a lot going on, but it's actually probably the minimum bar you need to have a totally like correct system. Most things it's common to make things idempotent today, so you can retry in case of failure. Canceling requests, I think we talk less about commutative properties on requests, but I think in order to cancel them correctly and not have weird side effects, they need to be commutative. We just don't talk about it as often. Okay, so if you have all of these properties with your requests, you get this guarantee that either all requests were completed successfully, if the saga completed successfully, so your business level thing happened, or a subset of requests and the corresponding compensating requests were executed. So basically, it's like the saga never executed, so I hold no hotel reservations, no car reservations. Distributed sagas, it's important to note, do not give you atomicity. You can see things that are happening as they happen, and does not give you isolation. So basically, this means that if I go book a hotel and then someone else tries to book the same hotel, but I got the last room, they will be rejected, like their request will fail. But then I go and cancel the request because like charging my credit card failed. Then the next person coming in can book the room. So that's what atomicity means. It doesn't mean that like people will see the intermediary states, but that's okay. That sort of like makes sense. Like the world is kind of eventually consistent, and especially in systems like this, you can kind of think of like where you can cancel or undo requests. It may just happen for other reasons as well. So this all sort of makes logical sense. And this is kind of the world we live in today. We don't have atomic transactions in a distributed sense across microservices. So basically, it gets us back to this guarantee, which may seem weak at first, but I think it's incredibly powerful. Instead of having to hand code a bunch of custom feral concurrency control logic, we can simply focus on what we want our applications to do and define those requests. So how do we define a distributed saga? Distributed sagas at their core are just directed acyclic graphs. And so basically, one of the things that this gives you, and is an extension of a previous talk, is the ability to sort of encode causality into the saga. So you'll have things, basically anything that is, you start executing the saga at the top and you walk down this graph, you can execute nodes in parallel as long as their parent, all the nodes in their parent route is complete. So you can execute car, hotel, and flight concurrently, but you can't charge the credit card until I have a car reservation, a hotel reservation, and a flight reservation in this saga graph. Each distributed saga vertex has a unique name, a request, like the information necessary to do the request, and the information necessary to execute the compensating request, and a status. And the status is the only mutable piece of state in this graph. And so there are two special nodes. There's a top and a bottom. I've just named them start and end saga for sort of clarity. And basically, it's just special nodes. Their requests are all no-ops, and they're just to say, like, hey, here's where you start so you can have children, and here's where you end so that you know you are done. You also need a distributed saga log to store intermediary state. This is fault-tolerant and highly available. You want to pick something that has, like, fairly high availability, because if you can't talk to the distributed saga log, you will not be able to make any kind of progress in the protocol. And then finally, you need some kind of saga execution coordinator. This is the thing that's actually going to execute your saga DAG and make the requests. It's really important to note that, like, unlike two-phase commit, you can actually have multiple of these things running per saga. It doesn't have to be the same one throughout the saga's execution lifetime. And you don't even have to have coordination to say there's only one working on it, because the requests are, in fact, idempotent. So I'm going to draw this as one on all the slides, but this could be many. It's like highly available, because you can have multiple of them. Okay, so let's talk about really quickly how we execute a distributed saga. So basically, we're going to start at the top of our Saga DAG, and we're going to get a request that comes in to say book trip request. It's going to have all the information necessary to book the trip. And so I start my Saga by basically saying, log a start Saga message to the log with any information I need to execute this Saga from the original request. And then once that is durably committed and responds that it is done, I can mark that node as complete. Then I can start going through and picking literally any, I could have picked car, hotel, or flight to execute, or actually execute them in parallel. That's like a performance optimization. For this example, we're going to go synchronously because it's easier to draw on slides. And so I'm going to just pick the hotel one because all of its parents are complete. It'll log a start hotel message to the log. Once that commits, I will then make the request to book the hotel request. And then once that happens, I'll get a response. It's going to work. And then I can log the end hotel message to the log along with any information that I made from the response that I might need later. So then I'm going to do the same thing for car, and I'm going to log in and make the request and then log the end message. I'm going to do the same thing for the flight. I'm going to go pretty fast through this just for time. All these slides will be online. And then finally, now I can execute the payment node because all of its parents are complete. So I'm going to start a payment, do the same thing, make the request, get the response, log it to the log. And now I'm at my end Saga node, and so I now know I'm done, and just I log an end Saga message, and then I mark everything as complete, and now our Saga has completed successfully. I hold reservations for a car, a hotel, and a flight, and I have been charged appropriately, and everything went fine. So let's talk about what happens when a distributed Saga fails. So say this is our Saga. What's happened here so far is we've executed the hotel, we've successfully booked it. We have a start flight message logged because we're running something in parallel, so we've started the flight node, but we haven't completed it. And then we're on our start car node. We're running that also in parallel with the flight, so we're going to book the request. The car service is going to say, no, I can't do that because, there are no cars on that date available. And so now we're going to log an abort car message to the log. At this point, once that's successfully logged, we now have to start rollback recovery because we know we can't fulfill our guarantee of you will have all of these requests executed to completion. So we're just going to start rolling things back and freeing any reservations we may have held. So in order to do this, we basically flip the graph. We flip all the the edges in the DAG. So the reason we do this is it holds some nice properties about causality. So I can preserve my invariance that that there are no payments, or there is a car reservation if I've been charged and things like that. So this preserves some nice invariance by walking this graph backwards. So we're going to start at the bottom. I've renamed the nodes. Once again, this is just the top and a bottom of a graph. I've renamed the node start comp Saga, so I'm going to start doing that. That has no ops associated with it. Now we execute the payment node. We look in our Saga log. There actually are no messages logged, which means this node never executed. The request for this node never executed. So we can just mark it as completed and moved on. I'm now going to go to my car node because it's the same principle of I can execute anything that's parents are completed in this DAG. It's going to ask for the entries. There's going to be a start and abort pair. So I know that request never successfully completed and there's nothing special happening there, so I don't have to execute a compensating request for it. Now if we ask the hotel for its log entries, I'm going to do get back start and end. Messages have been logged. That means I actively hold a hotel reservation, and so I have to execute the compensating request for it. So basically, the SEC will then go and make the cancel hotel request, which is stored in the vertex, the hotel vertex, on how to do that. I can use information that was stored in the end hotel request. So that's sort of a nice feature that we've extended and added with this from previous talks, because I am storing that data. So you can just say cancel the confirmation number that was in the end hotel request. I think that makes life a lot easier. And so then once that succeeds, I just log that I've successfully completed the comp hotel request, and then I can move on. And then finally, when I look at my flight, this one is kind of weird. I see that there is only a start entry logged there's only a start flight message logged in the log. And so now I'm in this weird spot where it may have completed, it may not have completed. I'm not really sure what happened here. And so to be totally sure and totally correct of what happened here, I'm going to actually execute that request until it succeeds, and I get a response back. Because our requests are idempotent, this is totally okay. So once I get the response back that it executed successfully, I do the same thing where I log the end flight message, and then I'm going to immediately go and run its compensating action to cancel it. And then I can log that I've compensated for this flight. This seems a little weird, especially in like the flight example, but it is really the only way to preserve the correctness guarantee that we want. If you know that like you can sort of just send comp hotel requests. There's like some variations you can get around it if you want to talk to me afterwards. But for like total correctness and in a general model, this is what you got to do. So now I'm finally at my end comp saga graph, and I just log that message because it's a no-op. And we still have our guarantee held that all requests were completed successfully, or a subset of requests, and the corresponding compensating requests were executed. So this is pretty powerful because basically all of this is held, all this logic is held in the Saga execution coordinator. It's not spread out throughout my entire code base. Okay, so I'm not going to go through Saga recovery because of time. If the SEC can fail, and like I mentioned, it can literally be the same, it can be a different process throughout the life cycle of a Saga. You can actually just read through the log, rehydrate state, and then go figure out what to execute from there. That's totally fine. I don't have time to walk through that, but I hope you can see that you can basically always reconstruct the state of the DAG from the example provided. So let's take a little quick walk of how, if we had built our travel application with Sagas, what it would look like. So had I started with just my hotel request, I would have made a hotel service that only does hotels. And then I would also have my payment API. And I would create a Saga that says book a hotel and then charge the person for the flight. And that's totally fine. I would then go and add the car. So I would just define a new Saga and spin up a car service. And then I would do the same thing for flights, where I would say, you know, make a flight, charge the payment, make a new Saga, and make those new services. So that's sort of comparable amount of work to where we were before, but I think this is where it gets really powerful, is now when we want to go and add trips, all I have to do is define a new Saga. I just say, like, these are the causality I want to enforce, and these are the invariants I want to enforce via this DAG, and then I just add it to the system, and I add some new API to my front end to kick off this start Saga in my SEC. And this is really powerful because we didn't have to go write a bunch of feral concurrency control logic. We can get this product to market much, we can get like the trips feature to market much faster just by having this sort of infrastructure already in place. Okay, so I really like Sagas because they have this great isolation of complex code. The complex code all lives in the SEC. And it's complex. It's not like terribly difficult to get right if you go and write it, but at least it's all in one place. As opposed to our microservices example where the complex code sort of lived everywhere because causality was spread and chaining was spread out throughout your whole system. It also gets more to the microservices and SOA belief of modular services, really. Like, this thing is only booking a flight. That's the only thing it has to know how to do. Whereas in our microservices example, it has to know how to book a flight, and it also has to know how to enforce the feral concurrency control mechanisms to make sure our payment invariants hold. And so this is a more modular service design. And really where I think it's powerful is now you truly have service composition. And it makes your designs and your services much more extensible because now I just add a new Saga if I want to use any of these things in some kind of new pattern or manner to enforce different invariants. Whereas here I have to add a whole new service, have new feral concurrency control mechanisms, and this gets really much more complicated. So I hope I've convinced you and given you some ideas of how distributed Sagas can make building and modifying your microservices easier. These slides will all be online. I will tweet them out after the fact, and thank you.
Hey, everybody. Okay, thanks a lot, Katie. This is another discussion period. We'll have about 10 minutes. I really encourage you to talk about the things you just heard about with somebody, and that I find whenever I express myself and express my thoughts, it helps me to really deeply ingest this information. But if I just kind of passively listen to it without expressing myself about it, it tends to slip out of my mind. So I'd really like you to try to talk about your feelings about the stuff that you're seeing on stage. All right, that'll be about 10 minutes, and then we'll be back with more. Hello. Hello, hello. All right, this ends the discussion period, but not the break between talks. We've still got about another 10 minutes or so before we're going to bring up the next talk. In this next 10 minutes, I'd like to encourage you to go, if you haven't yet, downstairs to the Lola's room and check out what's going on there. They've got the unconference board. If you have any ideas of things you want to talk about with others, you can just write that up on a little Post-it, stick it on the board, and have a conversation around that. In that area, we're also going to have the VR lab, the IoT lab, and massage therapy and acupuncture that is free to attendees starting at 11 o'clock. And that'll go from 11 o'clock until 3 o'clock. And if you've never had a massage from our provider, oh my gosh, they are amazing. So I really encourage you to do that. There's no reason not to. Let's see. Oh, there she is. Excellent. This is a good point for Dominica to show up. Hey, Dominica. So this is Dominica. You probably recognize her face. We've been working together for about 5 years now, and she has been doing massage for our audiences for a long time. In fact, she is a specialist in what she calls tech worker back, which is a real thing because you sit at a desk all day, you're hunched over, you're doing this kind of thing, and we have very unique repetitive stress issues. So here, let me give the mic to Dominica, and she'll explain a little bit more about what they're doing downstairs.
Thank you so much. So good to see you all. So glad to be back this year. We will be downstairs, Sybil and I'm Dominica. We will be downstairs providing mini treatments of massage and acupuncture. If you've never received, this is a really great opportunity. It's free to you, so you have no excuses. And we're downstairs in Lola's room. You can still see and hear the conference going on right next to where you're getting treatment, so you don't have to miss a thing. And we're here to answer any questions. So if you guys have questions about acupuncture or massage, please feel free to drop down there and ask us. See, we'll be there from 11 to 3. Is that right? Yeah. All right. Great to see you guys.
All right, and I'd also like to bring up one of our sponsors to talk a little bit about why they have put their hard-earned money into supporting this conference and why they care about you guys. So come on up, Ted. In fact, you might recognize this guy. He was one of our speakers last night at the welcome reception, and he did an amazing job. Everybody was super inspired. I was. So he's going to inspire you some more.
Well, I don't know about inspire for this talk, but hi, I'm Ted. I'm with Smartsheet. We're back there in the corner. Smartsheet crew represent. Whoa! That was, okay, normally they're a little bit more excited than that, but we are Smartsheet. We are basically a spreadsheet in the cloud that is principally used for project management and other sorts of group collaborative types of stuff. So if you've ever been part of a project where everybody was emailing Excel spreadsheets around to people, we fix that problem. That's basically what we do. We, growing like mad, we're in the hockey stick phase of our startup, the curve they talk about. When I started, which was about 7 months ago, there were about 400 people working for the company. There are now about 600. We're located in lovely downtown Bellevue, so you don't actually have to go into Seattle. You can actually live over there east side. And we're interested, anybody who's interested in coming up to Seattle and coming to work for us, by all means, come on up. And we are, as one of our VPs once put it, we are the biggest $850 million company that you've never heard of. So a large part of what we're doing here is basically to say, hi, we're here. Hi, I'm done.
Thanks so much, Ted. All right, so that's actually a really good segue to another thing you may have seen on the schedule that is a little unique and uncommon. We're going to do a thing called hiring speed dating. So you may have heard of speed dating, where you sit and meet somebody and talk to them for like a really short period of time, and then you decide you hate them and you don't ever want to talk to them again. And you don't have to. It's really cool. And you get to eat and drink while you do it. So this is kind of the same thing, but it is for jobs. So anybody who might be looking for a job or anybody who might be wanting to hire somebody, we're going to collect up downstairs tomorrow at this time at 10:30. to do this sort of hiring speed dating event. And that's a one-on-one. You get a minute to talk to each other about what it is, and we pair everybody up. Everybody gets to talk to everybody. So put that in the back of your head if you want to hire somebody, or if you might want to change jobs. You don't have to necessarily commit to it, but it's an opportunity to talk to people who might want to hire you. So that is coming up. All right, I'm going to shut up for a little bit, and then we'll have our next talk in about 5 minutes, I think.
Okay, we are going to get started again. How's everybody doing? Good. Okay. All right. All right, that's what I like to hear. Okay, so our next speaker, Jeremy Bellows, is from Dumont Industries. And Jeremy helps people who are frustrated solving complex problems with building software. And he is going to talk to us about neuroevolution. Take it away, Jeremy.
Hello. Thank you for being here. So I'm going to be talking today about neural evolution and specifically evolving neural topologies. So artificial intelligences are a growing part of our life. We use them every day, really. So what this talk is going to cover is what are artificial intelligence, what are neural networks, and how can we kind of evolve these neural networks to do whatever task we want. So first, a little bit about me. This is me, and that's my wife. I help people who are frustrated with complex problems, specializing in software. I have two different resources, my website as well as my GitHub. And we went over this, but we're going to go over what is a neuron, what is a sensor, what is an actuator, what is a neural network, and what is evolution. Finally, what is neuroevolution? Where to start? Okay, so originally where I learned about this was through this book by Gene Scher. In 2010, he created the DXNN system in Erlang. And this book explains that. I then created a prototype in F#. It's called Neuralfish. It's all open source, as well as Elixir, Elixir, which is built-in Elixir. And for those who don't know, Elixir compiles down to Erlang bytecode. The brain. So what is the brain? It's a very exciting thing. It powers our everyday movements, our everyday actions, our everyday judgments. And it's really just made up of a bunch of neurons. And a neuron consists of a cell body with dendrites going into that cell body. These dendrites connect to different neurons, and they receive electrical synapses, as well as chemical ones, into the cell body, which all gathers at the axon hillock. The axon hillock is like it's a disk, and the reason for this is that the neuron is an excitable cell. That means that if it hits a certain point, it's going to become excited. It's going to express its excitement to the other neurons that it's connected to. In order to accommodate for the latency that we experience with reality in all these different dendrites, we need to gather this electrical synapses at this axon hillock, which is simply a disk. And imagine these electrical impulses coming down into this disk, and it's spreading out across the surface area, the electrical values, I would say, in which after it reaches a certain point and becomes excited, it's going to send an electrical synapse along its axon to its axon terminal, which connects to other dendrites on other neurons. We can express this in our architecture like this. We have inbound connections, being if we express a neuron as maybe a process agent or a mailbox processor, then we can receive messages, and we're going to expect those messages from whatever we defined our inbound connections. We collect those synapses in the barrier to accommodate things not happening exactly at the same time. When this barrier is full, we then calculate the output synapse, and we send it to all the outbound connections. There's a little bit more to this. So when we receive a synapse, it's a raw synapse value. However, in the biological neuron, a dendrite can go either pretty far into the cell body or not so much, and we need to express this kind of this fluctuation of electrical energy as a weight. And so we express this as a neural connection weight. And simply put, the weighted synapse is equal to the raw synapse value multiplied by the neural connection weight. This allows us to learn. So for example, let's say you're learning how to how to use a wrench or maybe play the guitar. Over time, your movements, your thinking, your visual perception, your hearing perception, that all becomes very fine-tuned. You could think of this as your neural connections becoming very precise to whatever value you need to actually be able to do that correctly. This is just more of a demonstration of the synapse coming in, and then it's multiplied by the weight. So besides that, there are a whole bunch of neurons, but how do these neurons actually get values? It gets values from sensors, things like eyeballs, stuff like that. And a sensor has one job, to synchronize. Whenever we synchronize all of our sensors, it pulls in sensory data and it pushes it across the neural network. This looks like this, where we have a vector of data, and we take the first piece of data from that vector, and we send it to the first neuron. Take a second piece, second neuron, and third piece to the third neuron. This is an important thing to keep that order, because as we're evolving the neural networks, we need to have some type of consistency of how does the neural network understand what this data is going to do to which neuron. So a neuron has a function flow. And it's simply put, there's a barrier that receives a whole bunch of inputs and then takes all of those inputs once it has its full, and it sums them. After it sums them, we pass it to an activation function, which is completely configurable by the researcher or the programmer, whoever is running the simulations. After that, we output that sum, that modified sum value, to all of the outbound connections. Another example of the activation function is that we could take a large number and bound it between 0 and 1. It's really whatever you want to do to understand kind of the optimization and the functionality of your brain or your neural network. So the actuator is like an arm. It's something you act upon. And the actuator is very similar to a neuron. It has a barrier, and it receives a whole bunch of messages, or it receives a whole bunch of synapses from the neurons, and then it sums them. However, it doesn't run it through an activation function. Instead, it passes it to a high-order function that we have defined called an action function. And the action function is, it pretty much says, okay, you're an arm. This is how you're going to function. You're receiving this float value, and you're going to act upon it. So this is a basic neural network setup. We have a sensor which synchronizes, and then sends it along to the first neuron layer. It goes to the next one, goes to the actuator. It's a very basic one. It's called a feed-forward neural network. But that's not really how our complexity works. We actually have a lot of recursive connections, and recursive connections are simply put, our sensor synchronizes, it goes to the first neuron, and that goes over here to the second neuron. However, the second neuron has a connection to the first neuron. And so that synapse value, or the outbound value of that second neuron, is going to be stored for the next cycle of the neural network. This is effectively a memory circuit. Evolution. This is very exciting for me. So evolution, we've evolved over millions of years to where we are now to be able to think and to do the things we can. And how does it work? And more importantly, how can we use this concept to get to a solution, a neural network that is intelligent enough to operate in the environment we set for? A really great example of this is dodo birds. So we have a dodo bird, and it has a couple of offspring. And these offspring are all mutated. We've got an offspring with a different color, offspring with a hat, and an offspring that yells at us. So essentially, we pass these offsprings into a simulation. And after they're done in that simulation, we pass them into a fitness function. A fitness function essentially says, this offspring scored this amount. So that way we can compare how well did this dodo bird with the hat do versus this dodo bird who is able to talk. And the big thing about this is, in real life, is that evolution, or a fitness function for reality, is how many offspring did you have, how successful were those offspring in passing on their genes as well. And so we're able to score these different dodo birds, these offsprings, with our fitness function. This bird that was able to talk ended up scoring very high. And the bird that was a different color also scored pretty high. So if we were going to say we want 2/3 of our offsprings, our solutions, to continue on and pass their genes or their makeup, essentially the colored one and the one that speaks are going to win. Poor dodo bird with a hat. So we have topology mutations. This is how evolution, the concepts of that, of mutations, kind of go into neural networks. I showed you before a basic neural network connection. We can apply these mutations to that neural network after it has run to find offspring that could potentially perform better than its predecessors. A good example of this is the adneuron mutation. So the adneuron mutation is very simple. It randomly selects inside of the neural network a neural layer to add a neuron to, and then it randomly connects that neuron to any other node inside of the neural network, and it connects it to an output node. We can do all sorts of things with this. For example, add sensors. So let's say that we have a robot that's able to just roll forward. That means it's got an actuator, it's got wheels, and we want to get it to learn how to use its eye. So essentially, we could give it a color sensor, and we could get an infrared sensor, and instead of defining how exactly this neural network is going to work, how exactly these sensors are going to be connected into the neural network, we simply introduce it into a long generative simulation in which we're expecting at some point that the solution is going to learn how to use its sensors to be able to operate. It might not, though. That's the big thing. Life simulation. All right, so a basic very concept of life is eating. It's energy. We need it to act, we need it to grow, we need to consume things to be able to gather energy forth. And so there are some rules to this simulations. For example, entities must have a finite lifespan. That means they need to die after a certain amount of time, and this is essential to stop them from keeping further solutions from evolving. And the second thing is that entities must have an energy cost when they act, and it needs to also have an energy cost as time progresses. Also, food must be available, the right amount of food. If there's too much food available, then that means the solutions won't need to work as hard to get that food. If there's not enough food available and there's a lot of entities, that means the entities need to compete against each other over the food. So Gene Scher created this simulation in DXNN. It's pretty cool. It's just simple food gathering techniques. Let's see, I'm going to need to exit out of the slideshow. Give me 1 second. All right. So this is very simple. We'll restart it. So as you can see here, they're operating pretty intelligently. They have a sensor. It's a raycast. They're able to see in a direction at pretty much an angle. So they use this to identify each other as well as food that they're going to go eat. All of this just evolved naturally over the course of several generations, several hundred probably. So that's that. And zoom. All right, so we have another video, and this time it's the same simulation, but with walls. And the entities learned how to navigate around the walls to find the food. They also learned something very interesting that I will point out as soon as I find my mouse. All right. So notice over here in the corner, they're actually following each other. This is pretty cool. This is a social behavior that we're witnessing. And later on in the simulation, you'll see them run around up here just in a circle, continually following each other. It's a learned behavior that pretty much guarantees, or not guarantees, but increases the chance of them finding food and effectively having offspring. So I'm working on a life simulation as well, and I'm working with a very talented developer. His name is Nash Worth. He's creating some 3D worlds in the web browser, and I've got a demo of that too. So these aren't exactly, these aren't artificial networks. However, they are some interesting concepts that he discovered as he was creating this. So we have a bird here in the middle, and this bird is trying to find all of the different bugs. Right now the bird can't do anything, but we need to turn on some of the functionality. So we're going to turn on a hunting, and if you notice, it's starting to track and then run after it. Unfortunately, that's not enough to be able to catch up to those bugs, which are pretty fast. So we need to introduce a pouncing activity. So this pouncing activity, it uses energy in exchange for the potential to gain energy. This could be an example of an actuator that we evolve over time. Pretty cool. So if you would like to be notified when this 3D simulation comes out, I have a newsletter that you can sign up for on my website. Thank you very much. I appreciate this. And neural networks are definitely going to be an increasing part of our life, increasing part of our architectures as we evolve our technology. So, thank you.
Thank you, Jeremy. Okay, we're going to have a few minutes break, and then we will bring up our next speaker.
Cool. Thank you.
Especially with using someone else's laptop, you couldn't tell.
Hello, everyone. I just wanted to let you know real quick. This particular break is going to be a bit longer than the other ones. We've got about 20-ish minutes, 25 minutes. This is a great time to stretch your legs, get some fresh air outside, downstairs, maybe grab some more to eat. We're going to have lunch at noon, and one of the cool things, so as you're walking around here, you might smell this weird kind of yeasty, very exciting smell in the air. This place is actually a functioning brewery, as well as a ballroom, as well as a music venue and a bunch of other stuff. So on the second floor where Lola's room is at, there's a brewery right in front there that's currently brewing beer, and that's making this really cool smell in the room. It's making me really hungry and really want a beer. Well, the great thing is we will have an open bar at lunch, so if you're feeling like you're ready for a beer already at noon, or wine or soda or juice or whatever you want, the bar right back there will be available to everybody for free, and we'll have lunch lining up over here on the buffet table. That'll be at noon. We've got vegan options. We've got all kinds of everything that you could possibly want. It'll be really nice. So anyway, I just want to let you know that you've got a little bit of extra time this time, and we'll be back at 11:30. Thank you.
Okay.
What time are we going?
Hello, everybody. Hello. All right, we are ready for our next talk. This is the amazing Bobby Johnson, coming from Olympia, just around the corner. He is going to share with you a series of .NET Core cones. Take it away, Bobby.
Cool. Hi. Can everybody hear me okay? The switch is on. You guys can hear me okay? Great. All right. So it's been a little while since I've been in front of a room this large, so I'm a little nervous, so bear with me while I stuff the butterflies down. I have been involved for a long time with the Seattle Alt.NET group and did a lot of presentations around that group, helping to organize those conferences up in Seattle and that sort of thing. But as that movement kind of petered out in Seattle, I kind of stepped back and started to focus on my career a little bit and just do development type work. And when .NET Fringe started up a couple years ago, I really saw that as an opportunity to re-engage with that community that inspired me so much. And last year when I attended, I especially wanted to call out Julie Lerman. I had a conversation with her about how I wanted to re-engage with this community, and I wanted to be back in that place I was with the Alt.NET community. And she really encouraged me to try, and she pushed me, and now I'm here, and nervous as hell. So, yeah. So this is me. I go by Not Myself on just about every social media platform humanly available. If that name's not available, I don't go on that platform. I blog at this website, and you can see all of my open source code at that GitHub address. This is actually a picture of me at 17. Way back in '93, I grew up in Northwest Arkansas, and the Raiders were a huge deal in '93 in Northwest Arkansas. I actually didn't start working in the tech industry until I was 22. Up to that point, I actually worked in a Tyson chicken slaughterhouse. And eventually I felt that wasn't a very satisfying career, so I moved out to the Seattle area right as the .com bubble was blowing up. And I got a job working in tech support, doing support for Adobe Photoshop. And at that time, most of the people using Adobe Photoshop were very focused on print. And I kind of dug into all of the new web features that were coming out for Photoshop, and I learned what a web palette was, and I learned a little bit of HTML. And through that knowledge, I got a job at a startup who did tech support for other startups, right? And so, let's see. From there, I kind of worked at all of these places, just kind of building on experience, one on top of another, with, I guess, my most notable achievement is actually working on the team that got an Editor's Choice Award in the iTunes store for Stellar. So I've done quite a bit, everything from painful enterprise development to chaotic startups. One of the things that was consistent was working with great people who made a dramatic change in my career trajectory. Every place I worked at, I worked with great people. And I wanted to talk about, in the developer community that I've been involved with, we do a lot of hero worshiping, and we talk about, well, Ted Neward talks about this, and he knows what he's talking about, and he gives really great advice. And Uncle Bob, you should really read Uncle Bob because you're going to get a lot of good knowledge out of that. And all of that hero worship is absolutely earned. But as I was working at all of these places, the one thing that was consistent was I wasn't working with Ted Neward. I wasn't working with Uncle Bob. I was working with everyday developers. And those developers took time out of their lives to help me on that career path and get me moving in the right trajectory. And I could list probably hundreds of people that accomplished that with me, but I kind of want to call out a handful of them that were instrumental in helping me go down that development path. This person's name is Alex Johnson, and Alex Johnson was a web developer at that startup that I was talking about where we did tech support for other startups. And Alex was a full stack web developer back in '97, right, during the .com bubble. He wrote classic ASP, but he used JavaScript because VBScript is ooh, right? He took the time when I engaged with him to talk with me about how I could go from being that tech support guy for Adobe Photoshop who knew a little bit of HTML to actually my goal of becoming an actual web developer in those times. He basically said, you know a little bit of HTML, what you really need to do is you need to learn a programming language. And here we use JavaScript, so why don't you learn JavaScript? And he looked at my work, I would go write some code, and I would bring it back to him, and I'd go, look, Alex, I produced this. And he would critique it for me, and he would show me how I could improve that code. And he helped me focus to the point that I actually got my first web development job working with Alex. I interviewed, I passed the test, and I had enough skills that I was actually able to change from tech support to actual development. One thing to note about Alex is he actually passed away in 2015, so I never really got the opportunity to tell him this, right? So definitely talk to those mentors and let them know what they mean to you. The next person that I'd like to call out is Gene Limkel, and he's a very, very serious database guy. And Gene was kind of interesting because he was the first one that I worked with that viewed me as an actual developer. He actually talked to me in a way that he had confidence that I had the skill to be able to accomplish whatever task I was being assigned, right? Gene introduced me to basic concepts of object-oriented design. He helped me move from a very primitive obsession way of thinking into thinking about collaborative objects and how they interact with each other. He encouraged me also to make the transition from classic ASP into .NET way back when it was like version 1, right? I still know Gene. I still communicate with him regularly. And the last startup that I worked at, Taylorwell, he actually recruited me into it. I went and worked with him for a while again. He still treats me like a peer, and it's really satisfying. This person is Chris Bilson, and I met Chris Bilson through that Seattle alt.net group. And this was post.com bubble. And Chris was interesting because I was reading about Agile a lot, reading blog posts, but I didn't really implement any of those things. I read about the concepts, I understood the concepts, but I was kind of one of those developers who's like, well, this is like pie in the sky, nobody actually does this stuff. Chris actually did it, right? He encouraged me to explore other languages. He encouraged me to become very test-focused. He was a big open source advocate. I learned about in Hibernate through working with Chris. He encouraged me to explore other languages besides C# and JavaScript, if for no other reason, just to see how other platforms and other ecosystems approach problem solving, right? Chris also kind of encouraged me to start speaking locally. So I initially started doing code camps and our local users group. I would try to give little presentations. And eventually I started presenting at the alt.net national conference, which was a real boost in my career. Chris is still around with us as well. He's currently working, doing amazing things with Azure infrastructure team. And he was here last year, he's not here now, but I bump into him every now and then, and he was a huge influence in my career, so thanks, Chris. I kind of started off talking about hero worship and stuff, and I went and talked about everyday developers, but I want to do a little bit of hero worship at the moment. This is Jim Wyrick, and Jim was a Rubyist and an enthusiastic teacher, as well as a board game fanatic. He was heavily involved in the software craftsmanship movement several years back. And he was a teacher who really encouraged beginners to experiment and be playful. And he's probably the friendliest guy on the planet that I've ever met. and he unfortunately also passed away in 2014. And one of the combining things of all of these people that I'm mentioning, other than them being white guys, is that they were all teachers and mentors above and beyond their day-to-day job, right? They could have been that little stereotypical walled-off developer that just sat in a corner and did their job and didn't care about everyone else in the world. But these people, these everyday developers, chose to invest time in the people around them and encourage them to learn new skills. They were all focused on continuous improvement of not only themselves, but their teams and their community around them. And I'll give you an example of that through Jim. Jim is kind of best known, I guess, for being the author of the Ruby Cones, which is a teaching tool that helps you learn Ruby and the basic syntax of Ruby and how to structure Ruby applications by putting your hands on a keyboard and actually writing Ruby code. And I want to show you a little demo of that quickly. Can you guys see that okay? Okay, so the Ruby cones are a set of unit tests, basically, that execute one at a time until they reach the first failing unit test. And this is the output that you get when you run with Ruby cones. You can see up at the top that the first cone that I'm working on is about asserts, and the very first one failed. It gives me a little bit of playful encouragement about continuing on and learning Ruby. And then it gives me some information about, hey, go to this file and look at this place and fix whatever's wrong with this code. So let's take a look at what that code looks like. All right. You guys see that okay? All right, and I should have the I can try. Control plus. Hey, there we go. Okay. So one of the cool things about the Ruby cones is it's code. You're literally looking at Ruby syntax, and there are comments that are all around about what you need to do to solve these problems. And the very first one that failed was test assert truth, right? So if I go over there and I can actually get my cursor in place. Damn. And so now you can see the output has changed slightly. The very first test, I've passed that. It's expanded my awareness of how to do asserts in Ruby. It gives me some more encouragement, and then tells me where the next issue is that I need to resolve. And basically what you do is you progress through these set of unit tests that introduce you slowly to concepts in Ruby, and by the end of it, you have a fairly decent understanding of how to use the language. When I first encountered this, I kind of fell in love with it. I thought it was amazing. I'd never seen a teaching method like this to get new developers hands on keyboard in such a quick way and actually writing code. So what I did was I started doing presentations using the Ruby cones, and what I would do is I would come up on stage and I would talk about Ruby and how it's an interesting language and what makes it interesting as a dynamic language versus a static language or functional language or something like that. And then I would bring up the cones and I would do the first one. And I would basically go through the audience, and I'd have somebody come up on the stage and they would do the next one. And we'd go through as far as we could possibly go through the cones in the allotted time. And at the end of the session, I would say, okay, you're all Rubyists now. You know how to write Ruby code. Go forth and be awesome. And I probably did that, gosh, I don't know, probably 20 times that gave that little presentation. And it was very satisfying. And a few years ago, several years ago, I went to Software Craftsmanship North America in Chicago. And Jim was there. And he was presenting, and he presented on his thing. I think he did the Roman numerals kata live in front of an audience, and the guy was really jovial and just full of joy and really inspiring in that way. And we happened to be staying at the same hotel. And after the conference that night, he set up a big board game, and everybody was just welcome to come sit with him and play this board game. And so I did it. And I kind of told him about this thing that I was doing, with his work. And I was a little nervous because it's like I'm telling this guy, hey, I took your work and I'm kind of doing my own thing with it and being successful with it, and haha. And his response was really amazing. His response was, I've never heard of that. That's a really good idea. You should keep doing it. And that kind of led me to a couple other situations in recent years. I was at a talk by Scott Hanselman a while back. And I don't remember the exact content of the talk, but the gist that I took away from it was he was considering .NET in terms of these coding dojos that people do, and workshops and that sort of thing, and the huge barrier to entry to get a novice developer into the .NET ecosystem. And that huge barrier to entry is Visual Studio, all the installers, SQL Server, all this sort of stuff. And when you're going into a coding dojo to do this sort of stuff, the people just aren't interested in installing all that stuff when you can just download Node and start hacking, right? So with the release of .NET Core, I saw an opportunity. Can you guys see that? No. There we go. There we go. I saw an opportunity to create a project that was very similar to what Jim had done. And the goal being get someone's hands on a keyboard writing C# as quickly as possible. And I had some other ulterior motives that I wanted to involve in that. One of them was I wanted to encourage people that were in the .NET space to start contributing to open source projects. From my background, .NET has not been very open source friendly, and there are a lot of developers that don't even consider it. So I wanted to, like Scott was saying, cast or Sean, a wider net and get more people involved in open source projects. And this is kind of how I did it. I created the project. I actually cloned a lot of the cones from Corey Foy's .NET Cones project, and I put it up on GitHub, and I blogged about it a little bit. I created a build and a Gitter where people can come in and ask me questions. I created the simplest possible getting started guide that I could for how to get in and start working with the cones themselves. And then I put a blurb down at the bottom about contributing back to this project. If you want to create a cone and talk about string interpolation, do it. I also took the time to call out the inspiration and other people, the developers that I was standing on their shoulders about as well. I also took the time to lay out some issues. And we heard earlier about Up for Grabs, so I registered my project on Up for Grabs, and I tag things as Up for Grabs, and tag things that are beginner friendly. And really all I did with this is blog about it and kind of talk about it on Twitter. And I started getting pull requests for adding features into my little project. And one of the ways that I encourage people to keep coming back or show appreciation for them is I would accept their pull request, and I'd give them a screenshot showing my gratitude. Thank you. Please come back. Right? So I'll show you a couple examples of those because they're fun. So there's another one. Yeah, thanks. And probably the proudest thing that I'm proud of with regards to this tiny little project that's unassuming and people feel, comfortable contributing to is the number of people that tell me this. Thanks for accepting. This was my first pull request. And, I give them some encouragement, and so far, the project's been going really well. And I'm pretty happy with that. So that is kind of all I have to say. And I will leave you with that. Thank you for listening to me.
All right, everybody. So we have arrived at what you've all been waiting for, maybe. I don't know if you've been waiting for it or not. Lunch break. All right. So they are still setting up the buffet, so please don't rush over here because it's not quite ready. Give them about 5 minutes or so, and then lunch will be served. One way you can spend that 5 minutes is by going over to the bar in the back and grabbing yourself a beverage. Alcoholic, non-alcoholic are all available. Also down in Lola's room, we have a secondary bar down there, which you may or may not know is also open. So if you want to go chill out in Lola's room and grab a table down there or grab a massage, you can also have a drink down there. So yeah, give them a few minutes and then enjoy lunch. After that, we'll be back with lightning talks at 1 o'clock and then resume the normal presentations after the lightning talks. Thanks a lot. So you might think about doing that. You don't have to. But if you want to do that, if you want to meet new people, it's a great time to do it. Lunch is a perfect time to share a meal and get to know somebody new. Okay, that's all. Bye.